I'm the founder of 10xcoderkids.com, and if you like this video, please don't forget to smash the like button and share this video with as many people as you can. And if you haven't subscribed to my channel yet, kindly do it so that you don't miss any of my videos. So without any delay, let's get started. And today we are gonna learn about recursion in C++. So today we are going to learn about the topic of recursion in C++, and this is going to be very interesting. So without any delay, let's get started. Damn! So what exactly is recursion? First of all, I need to tell you that recursion is a very simple concept if you want to learn about it. If you are just like, if you just want to mock it up and learn it for some reason, like if you are forced to do it, then you will not be able to learn what it exactly is. But if you want to learn it, then this is a very easy concept for you. And recursion basically is a concept where you call, like for example, you have a function sum, then you call that function sum inside that own it inside your own function. So I've called sum inside sum only, right? So that is recursion. So we're gonna see an example of recursion over here and understand what is recursion through this example. So first of all, we are including IOStream and using namespace standard. This is usual. Then we have a sum function. It is taking an int k, right? So it is taking an integer k. If k is greater than 0, then it will return k plus some k minus 1, else it will return 0. So we'll come back to this afterwards. First we'll look at the main function. We have int result sum 10. Then we are printing the result, right? And then we are returning 0. Quite cool. So I'll just open up notes over here. So to give you a proper understanding. Okay, so here we have a note. So over here, what is happening? We are calling sum. So result right now. Okay, so recursion result is equals to sum 10. So what is sum 10 returning us? It is checking that if k is greater than 0, 10 is greater than 0. So it is returning k, that is 10. So it is returning 10 plus some k minus 1. So k is 10, so 10 minus 1 is 9. So it is returning us 10 plus some 9. So now what is sum 9? It is checking that if k is greater than 0, then so 9 is greater than 0. So it is returning k. That means it is returning 9 plus some k minus 1. So k minus 1 is 8. 9 minus 1 is 8. So we get sum 8. Then 8 is passed to sum. It checks if 8 is greater than 0, right? So 8 is greater than 0. So that's why it returns us k. So it returns us 8 plus sum k minus 1, that is 8 minus 1, that is equals to 7. And this goes on for so long, and this will be like 7 plus 6 plus, it will go on like 5 plus 4 plus 3 plus sum 2. So it will keep on going till you reach sum 2. So now when you reach sum 2, it will check if 2 is greater than 0, 2 is greater than 0. So it will return the k value, so it is 2 plus sum k minus 1, that is 1. Then 1 is passed to sum. It checks if k is greater, if 1 is greater than 0, it is, so it returns 1 plus k minus 1 plus sum k minus 1, that is sum 0. So now when it reaches sum 0, it checks if k is greater than 0. So 0 is not greater than 0, it returns 0. And now further, now this function now we have our final result, that is this, right? The addition of this is the final result. So now there is no more calls of sum, because we have reached to a certain condition where this calling of this function sum again and again stops. We have reached the condition where k is not greater than 0, and it will return us 0 only. It is not continuing further, as we have not returned a call to sum. right? So if we had for example, if there was this else block did not exist, so this would have gone in an infinite loop. It would have checked if k is greater than 0. uh, okay, so it is not going into an infinite loop over here, because if k is not greater than 0, then it won't return us anything. It will bring us an error right now because of this, because we don't get some value from uh, a potent function, a certain function call. So when this reaches to sum 0, so you can see we have an error over here, because when this reaches when it calls sum 0, so I'll show you notes. Okay, so when this reaches to sum 0, right, then it checks if 0 is greater than 0. It is not, so it does not return us anything, so we get no value over here. We get undefined or null over here, right? So undefined or null cannot be added, so that's why it is bringing an error. So now over here, as you can see, there's else over here. So when in recursion, when you are calling a function that like the same function inside the function, so for example, if you're calling sum inside sum, you need to be very careful with it, as you will always need a terminating condition. If you don't have a terminating condition, either it will go into an infinite loop, or it will go into it will lead to an error, right? So you should always be very careful while using recursion. It can be quite easy to slip into writing a function which never terminates, or one that uses excess amounts of memory or processor power. However, when written correctly, recursion can be very efficient. You can see this is very efficient right now to add like all the numbers between 10 and 0, and mathematically elegant approach to programming, right? So this is a very good approach over here, right? You An alternative of recursion is also loops, right? But recursion is also, you will get to know when should you exactly use recursion, when you want to yeah, okay, you will get to know when you need to use recursion. But right now, this is the concept of recursion, where you call of the same function inside a function. So you have a sum function, you call the sum function inside the sum function, right? And you always need a terminating condition in your sum function, in your recursive function, where it should terminate the function at some point of time, right? um, the second thing, when it is not terminating, it should be kept on calling again and again, right? So when a certain condition is passed and that is not the terminating condition, then it should the same function should be called again, so that there is a recursive behavior, right? So you saw the recursive behavior. It first gave us 10 and some 9, then it gave us 9 and some 8, then it gave us 8 and some 7, then it gave us 7 and some 6, right? And so on, gave us till it reached some 0. And when it reached some 0, it checked if 0 is greater than 0. It wasn't greater than 0, so it returned a 0. And there was the sum function was not called once again over here, and no more recursive no more no more calls for sum were there left, right? So there were no more calls to sum, and the function ended. And in the end, we get the result 55, right? Because 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is plus 0 is also logically 55. So it's taking a while over here. I don't know why. So okay, so it's taking a while. Okay, so I'll just see you in a second. Got the result 55. I just reloaded the tab and then tried to run it, so it ran. So we get the result 55, as you can see, and this is a very efficient method, like mathematically elegant approach to programming. So this was it, guys, for this video. I hope you guys liked the video, guys. If you did, please don't forget to smash the like button and share this video with as many people as you can. Thank you guys. Bye. Stay safe, stay healthy, and keep watching my videos. Dab!